Right, so let's start again, right? So here are some tips that I find useful for trigonometry, at least for college algebra, the 190 right level. So some useful identities. So here is number one, right? Sine of negative x, right, is going to equal to negative sine of x. Because it satisfies this property, sine is known as an odd function, right? This is useful because think about this, right? What will be sine of negative 30 degrees? Well, you can pull out the negative outside of the sign, and this will become negative sine of 30 degrees. And what is this going to equal to? Negative 1 over 2. That's very useful if you're evaluating sine at negative angles, right? You can easily put the negative outside, and I think that saves you a lot of time.
Well, why would it be negative? Why would the angle be negative?
So the negative just tells you that instead of going counterclockwise, you went clockwise. Yeah, that's all. This
could you find
coterminal?
coterminal?
Yeah, and the reference as well.
So this is just making it short.
Yeah, and so this one is just telling you, hey, don't waste your time. So this is quadrant 4, right?
Yeah.
So you went backwards. You went clockwise like this, right? And what is the reference angle? The reference angle will be just this angle right here, right? Reference,
Okay.
yeah,
Yeah.
angle. And in this case, the reference angle is just 30 degrees, right?
Yeah.
And sine over there, right? Sine is negative, right? So it makes sense that the answer is negative 1/2. Yeah, but just some useful information, right? And so the second one, number 2, we have cosine of negative x. Cosine of negative x is equal to cosine of x. Because it satisfies this property, cosine is known as an even function, right? And this is useful because think about it like this, right? If you're evaluating cosine of negative, let's put 30 degrees, right? Having a negative in the input it doesn't mean anything for cosine. This is the same thing as cosine of 30 degrees. It doesn't do anything much. Nothing at all, right? So what is cosine of 30? That's radical 3 over 2. And it makes sense because, again, negative 30 degrees will be in the fourth quadrant. Cosine there will be positive, right? So, so regardless of that. And even if it's in the second, third, fourth, it doesn't matter which quadrant it is. Cosine is an even function. Number 3, tangent of negative x will equal to negative tangent of x. Like that. And again, these will be useful because if you're doing tangent of negative 30, this is going to be negative tangent of 30. And negative tangent of 30, that will be just negative 1 over radical 3. Or you can write it as negative radical 3 over 3. Right? But again, if you remember the chart that I gave you, right, your sine and cosine, you can still figure it out that tangent of 30 will be sine of 30 divided by cosine of 30. And you will see that you get negative 1 over radical 3 with the negative in front of this, right? And so besides these 3 identities, here are other identities. If you remember yesterday, we talked about these identities. We called this the Pythagorean. Yeah, well, this one, right? The Pythagorean identities for trigonometry. Number 4, we talked about this. Yes, do you guys remember y cosine squared plus sine squared? Right. What is this equal to?
1.
Do you guys remember y is equal to 1?
Yeah.
Because the x, right, and the y, x is cosine, y is sine, and we get this from the unit circle, right? X squared plus y squared equals 1, a unit circle, and x is representing the cosine value, and y is representing the sine value in a unit circle, right? So we get that identity. And number 5, right? If you were to divide, right? So let's use our imagination a little bit. For the first, number 4, right? For this one, if you were to divide everything by cosine squared, if you divide everything by cosine squared, you're going to get this. Cosine squared theta over cosine squared, right? Theta plus sine squared theta divided by cosine squared equals to 1 over cosine squared theta. And cosine squared over cosine squared, this will be simplified into 1 plus sine squared over cosine squared. Sine over cosine is tangent. So sine squared over cosine squared will be tangent squared. And then 1 over cosine over there will be secant. 1 over cosine squared will be secant squared. You have seen this second identity as well, right? Somewhere. Mm-hmm. But you see how we get it from the first, number 4, right? We divide everything by cosine squared. And number 6, if from number 4 again, we divide instead of by cosine squared, we divide by sine squared, we're going to get this. Cosine squared theta over sine squared theta plus sine squared theta over sine squared theta equals to 1 over sine squared. What are we going to get here? Now we're going to get cosine over sine. Cosine over sine here is cotangent. So cosine squared over sine squared will be cotangent squared theta. And plus sine squared over sine squared, that's just going to be 1 equals to 1 over sine theta will be cosecant. So 1 over sine squared will be cosecant, cosecant squared theta. So we get these new identities. So this is number 4. This is number 5. And this one is number 6. But these are useful identities. There are many other identities. And again, it's really hard to remember them. So for now, we're just going to look at them, and this is perfectly fine.
Do you have to memorize them like the first two?
You should memorize them, but I will try to. We'll try to see how they all are connected, and you can evaluate all of the problems that we're going to do without them. You can evaluate it without them, but if you know them, that will make things a little bit easier. Yeah, but it's not like a requirement, right? You can get away with that without it. Here's a question, right? Here's an example. Suppose that if tangent theta, right, is equal to 2 over 3, right? Just imagine if tangent theta is equal to 2 over 3, and I tell you that theta is in quadrant 3. Find cosine theta and sine theta. Yeah, like this. Sine theta and cosine theta. Find the other ones. So just remember, if tangent theta equals 2 over 3 and theta is in quadrant 3, find cosine theta and sine theta. Let's do this in let's see. Yeah, let's do this in 2 different ways, right? So you can have a possibility of what do I mean by remembered identities, don't remembered identities, right? Number 1 is like without the identities. Without these identities, how will we do this? Well, theta is in which quadrant? Third quadrant. And remember how we how did we came up with sine and cosine? They're nothing more but ratios on a right triangle. So we're gonna try to see if we can draw a right triangle, but the right triangle will be in quadrant 3. And from there we're gonna see if this makes sense or not. So here is what we have. There we go. So here's x, here's y, and here's quadrant 3. Here, quadrant 3. And what we're going to do is we're going to draw a little triangle there. Let's see. There you go. That's too bad, yeah. Okay, there you go. And here and here. So here is a right triangle. But you see how I created in the third quadrant? Yeah, I used the fact that theta was in the third quadrant, right? Oh, now all I did was use this to create a right triangle there on it. What would be the this side right here, the length of this side here. This side, what will that be?
3.
Yeah. So theta, maybe theta, it will be convenient for us to call these theta right here. That theta. And tangent theta, if you remember, that was right opposite over adjacent. Mhm. So the opposite to tangent will be 2 over 3, right? So opposite to tangent here will be 2. But the problem with doing that is that we want to be consistent. Since this is in the third quadrant, and the opposite guy will be the y value of that, it will be better for us to put -2 like this. You just a little bit better. You don't have to do this, but if you do it, it will be just a little bit better because you're very consistent on it. That the y value there is -2. If you put +2, it's not going to make a big difference. And what?
Then why is it a positive 2, 3?
Because what about the other side over there?
It's -3.
But it's also in the negative x.
Okay.
So that would be negative
Be negative.
-3. So the negatives will cancel out. So in reality, it's in quadrant 3, so they're both negatives, right? Now, what will be the hypotenuse of this guy here?
Square root of 13.
Yeah. So is it clear how we find the hypotenuse for this one?
Pythagorean.
Yeah, Pythagorean's theorem. So this guy is going to be the square root of -2 squared plus -3 squared, right? Right. So this is going to be the square root of 13. Perfect. We have everything that we need in this triangle.
Why didn't you use the identity that you
I said we're going to do it in two different ways. Number one will be without the identities, and number two will be applying the identities. Yeah. So the identities are not required. They're just going to be making your life a little bit easier, right? But
I do one thing like
uh-huh.
it says tangent data is 2/3, but why did you put -2 and then -3?
Yeah. Again, if I draw a point, right? If I draw a point over here, if I draw a point, any point over there, and I call this x, y, give me a point on the third quadrant there. Any point on it.
So any point on the third quadrant?
Yeah.
-3, -27.
Yeah. So let me put -3, -2. You agree with me that will be in the third quadrant?
Yeah.
Yeah. What will be these length right here? This side right here. This will be -2, right? That's what I mean. That this will be the -2. And what about this guy right here? This one over here on the right side. So this will be -3 here. Sorry, -3. And on the other side, the height over there will be -2. So that's what I just draw a little triangle there, and I call this height 2 or -2. It doesn't matter. I put negative there because it's in the third quadrant, just to use those coordinates. But it wouldn't matter. It wouldn't. You get the same answer if you use positives. You will get exactly the same answer if you use the positive ones. Right? It's just that having a negatives will make things a little bit easier, because what is sine theta now? If you use this one, what is sine theta?
-2 of the square root.
Yeah, but for the triangle, it will be opposite over the hypotenuse, right? And opposite to the theta value will be -2 divided by
Square root of 13.
square root of 13th. Now you see, you didn't have to worry about putting a negative there. It came along with it from the diagram. So if you use +2 and +3, you still have to think about the sign of sine in the third quadrant. Is the sign of this one positive or negative? Because it's on the third quadrant. But because we were careful on labeling the negatives, that's something we don't have to worry about. It already comes for free. So if you were to use positive and positive, that wouldn't matter either. It wouldn't matter because now you have to figure it out. The sign in the third quadrant should have a negative sign, right? But because we attach the negatives on it, right, we didn't have to worry about that.
It's like a little reminder.
Yeah, it's a little reminder. Yeah. So the -3 is just representing the x position, right? And the -2 is representing the y position of those points over there. But you could have used the +2 and 3. It's just that that I want to make a remark that points in the third quadrant will have negative, right, values, right? -3, -2, for example.
Now you get rid of the square root of 13, right?
Well, this is fine, right? Sine theta will be opposite, which is -2, and the hypotenuse we already found that's a square root of 13, which is good. Yeah, and you don't have to rationalize your answer. This is fine. But if you did rationalize your answer, it will be negative 2 radical 13 over, 13th. Yeah, but you don't have to rationalize. If they don't say rationalize your answer, you don't need to do that. What about cosine theta? It will be adjacent over, hypotenuse. And what is this going to be? Yeah, adjacent will be negative 3 over hypotenuse, which is radical 13th, and you don't even have to worry about the signs. The sign is already there. So if you get positive 3 over radical 13, you have to question, right, if you get it right or not. Theta here is in the third quadrant, so cosine is expected to be negative. Or you can rationalize it like this, but it's not a requirement because it doesn't say it, right? But that's perfectly fine. Right. So that's number one. That's how we evaluate them without the identities. Now let's apply the identities now, or the identity that might be useful, right? So what are we given? We're given tangent, right? If we take a look at these three identities here, which one will be useful? The first one, second, or third one? But we're given tangent, right? We're told that tangent theta is 2 over 3.
The first.
Well, the second one. If you're given tangent theta is 2 over 3, that's the one that has tangent in it, right? Yeah. So I'm gonna apply the identity number 5, right? So applying the second way that we're gonna do this is applying the identity. This is 1 plus tangent square theta. What is this equal to?
Secant squared.
Yeah. And if you know secant, do you know cosine? Yeah, and that makes things a little bit easier, right? So we are given that tangent theta is equal to, and theta is in quadrant 3. Two things, right? So we have 1 plus tangent squared equals to secant squared, right? What do we know about tangents? Tangent is 2 over 3, right? So we're going to have 1 plus 4 over 9 equals to secant squared theta. So what is this guy going to be? 13 over 9, yeah, equals to?
Secant squared.
Yeah, so what is secant theta?
Square root of 13 over 3.
Yeah, but it could be positive or negative.
Yeah.
It could be either way, right? So positive, negative, radical 13 over radical 9, which is 3. So why do we select the negative one instead of the?
Yes, in quadrant number 3.
Yeah, because we are reminded that in quadrant 3, cosine will be negative. So secant, the reciprocal of that, will still be negative. You're not doing the negative reciprocal of it. You're just doing the reciprocal of this, right? So we know that cosine theta, it will be negative 3 over its square root of 13th. So now we know cosine. How do you know what sine is? You can use the first identity if you wanted to, right? If you wanted to. So using the first identity, that cosine squared theta plus sine squared theta, they add up to 1. And the fact, right, that theta is still in quadrant 3, right? You will know that this will be negative 3 over radical 13th squared plus sine squared. This is equal to 1. So this will be 9th over plus sine squared theta equals to 1. So what is sine squared equal to? 1 minus?
So 5 over 13.
Yeah. Not 5, 4. Yeah. So sine squared, yeah, sine squared equals to that is equal to 4 over 13th. So what is sine theta equal to?
Negative 4 over 13.
Yeah, but it would be plus or minus, right?
Plus or minus 2 over 3.
But we decide the negative because the theta is in quadrant 3. So it'll be plus or minus 2 over, yeah, and then we decide that, hey, we're going to select the negative one. And we select the negative one because theta is in quadrant 3. So we get this one. We get that sine theta should be positive 2 over negative 2 over radical 13th, and so we get the answer for that as well. Did the answers get us the same answers as the one before? Yeah, but this one was just using identities and the fact that theta is in quadrant 3. We got the same exact results, right? This one is a little bit easier because, right, you're using the theta and tangent theta as opposite of our adjacent to create a little right triangle, and everything just falls into place. The identities here, you have to manipulate algebra a little bit more, right? And you do get the answer there. I want to show you something. I'll come back to this one. I want to show you something before anything. So imagine. So let's go to Desmos, right? Desmos. There you go. Here. Imagine, remember the unit circle that we drew yesterday? Cosine squared plus sine squared equals 1, right? Let me just write it like this. X squared plus y squared equals to 1. That should give me the unit circle. There you go. And you see, I keep on saying that you see theta values in the x, y axis, but here you don't see theta values. You only see the rectangular coordinate system, the x and y. They have options. Every time you use a software, they should have an option here. Like, for example, on the right side, they say you can use grids, or you can use arrows, right? Or you can use polar coordinates if you want to, like this. You see? All of a sudden, you're able to see. Can I change the yeah. No. That was good, yeah. So, do you see the theta values or no? You see what you're given here for theta? Theta is equal to pi over 6, right? Theta is equal to pi over 4. You're given the theta values depending on which point you are located on. For example, let's locate a point, right? Like, I'm gonna put a point here, and let's just say that, hey,
Can you make the slider too?
yeah, you can make it run, and you can make it make it run in a circle. Later on, you'll learn how to make it not just run on a circle, but you make this run on a bigger circle and bigger circle, and we're gonna call that coordinate system a polar coordinate system, right? Where you identify a point not by x comma y, a rectangular coordinate system, but you are gonna identify a point by an r value and a theta value, and those are gonna be the variables now, not x and y. Everything will be in terms of r and theta. It's more realistic, and then you learn that also has limitations. So you learn different coordinate systems. For now, imagine that I identify a point, like the point that we were talking about. Let me just put -3 divided by the square root of 13th. That's the x value. What was the y value? The y value is a sine value, right? What was this? 2 over?
Square root of 13.
Yeah, negative, right?
Yeah.
Okay, negative 2.
Over.
Yeah, over the square root of. And I drew the unit circle just to let you know, hey, don't forget that all of these are going to lie on the unit circle, right? Like this. Do you see that point over there? It's hard to see it, right? Yeah. Do you see that the point that we drew over there is on the unit circle? Everything that we find in sine, cosine, tangent, they're always going to be on the unit circle. Do you see that that's going to be a point in the third quadrant? It's hard to see that there will be a little triangle formed there, but you can still figure it out. But all of a sudden, you don't see the rectangles that you saw. The grids that we saw before were something like this, right? We can change that now into things like this one, where you all of a sudden you can see the angles that it creates, right? Instead of just the x and y coordinates.
How could you use it in the real world?
More than you can think. For example, how do we create soda cans? The machine must be able to cut this in radius, right? And you can increase this size a little bit more. Everything that we learn is in x and y. Imagine I'll give you this right here. This is called, and hopefully you have a little bit of idea. If you don't have an idea, that's fine. Imagine I give you this. R equals to, I'm just going to put R equals to, and I put 2 times cosine theta. Let's see if this reads it. 2 times cosine theta. And I'm going to add plus 3 onto, plus 3. What I just did right now is I made a relationship between r and theta. So instead of x and y's, I'm going to write every equation that I know of in terms of r and theta. And what pictures did I get in this case? Look. It's not a unit circle. It's like a bent. We call this a lemicon. Yeah, but you see the shape. It's hard to see. Let me put this back into this. Do you see that shape? Yeah, it's weird, right? What is the area of that thing? If you wanted to design something like that for whatever reason, what if you want to use this one? This is a flower, right? By the way, if I put, if I put 2 cosine of 3 theta, right? Let me put 3 theta. Look at that. You see what I get over there?
Flower.
Yeah, and you can design things like this, like logos or anything like you want, right? What if instead of 3 theta, I put 4 theta? It's more interesting because all of a sudden, look how many petals you have.
Oh my.
Yeah. Right?
That's a nice flower.
Yeah.
I like it.
Yeah, and if you put r equals to, say r equals to 2, for example. R equals to 2. Look, you just designed something like this, like really nice, right?
Yeah, now that looks like textile.
Yeah. But it's a nice logo, right? And it didn't take you long to create. If you knew how to manipulate this, would be really nice. And you can increase the radius of this right here. You see, right, like that, and make different shapes. But you can create things like that, and it doesn't have to be rectangles, right? Boxes. You can create things like this. And what you can do is you can make this animation, make a little ball bounce, right? But you can create a lot of little things, but you have to understand how they work and so on. But for now, let's go back to this right here. So we are describing points by using thetas now, and all of these points are going to be in a unit circle. Later on, you're going to learn that you don't have to fix every point in the unit circle. You can manipulate that distance as well. And for now, we answered this question. Let's take a look at this next problem here. Let's see if this makes sense, right? Similar to what we did. And this time, I'll tell you if sine theta is equal to -4/5, right? And theta is in quadrant 4, I will ask you to find, right? Find cosine theta and tangent theta, like this. Find cosine theta and tangent theta. So if sine theta equals -4/5 and theta is in quadrant 4, which way do you? Let's do it both ways again by using identities and let's start off with drawing a little right triangle. So without identities. In the exams, they won't tell you use an identity, and they won't even tell you which identities you have to use. You can answer the question whichever way you like. And some people later on in mathematics, they become really creative on how to answer things, and you're surprised like that they're able to come up in their own way of figuring things out, and it works. And later on, if you learn something in class, it doesn't mean that everything else is wrong. If you want to do it your own way, you can do it your own way, as long as it makes sense. So without identities. So here is what we have. We have a theta value in quadrant 4. So we're going to have something like this in the fourth quadrant. We don't know what theta is, right? All we are giving is that sine theta will be negative 4 over 5. And we're also given that theta is in quadrant 4. So this is what we have. I'm going to draw a little triangle there. And this is what I have here. And here is theta. And what do we know? Since we know that sine theta is opposite, right, over hypotenuse, what do we know about the opposite one? Well, we have negative 4 over 5, right? So let's try to see if we can label this out, right? So we're going to have 4 here as the opposite, right? And 5 as the hypotenuse here. Right, let me put some this right here. So here's 4 and here is 5. We are going to put the negative on the 4. This is the representing that the y coordinate will have a negative value. This hypotenuse, the hypotenuse, we never put a negative on the hypotenuse ever. We always put the negatives on the x or y places. And is it clear why it will be negative 4? Because the y coordinate will be negative there. You can use positive 4 if you want to, but again, you have to determine the signs later on, whether they're positive or negatives. We are still have to figure out the missing side here.
3.
So this will be the square root of 5 squared, right? Minus 4 squared. And this will be the square root of 25 minus 16th, which becomes the square root of 9, which is 3. And you are familiar with the 3, 4, 5 triangle somehow, right? And back in high school, sometimes they will even give you the approximate values of what theta is. But again, here we don't want to give what a theta value is, because theta is not that value. Theta is again, you cannot express theta something else. So, for example, if you wanted to know what this is, you can have a calculator, and it will tell you about, I think, 38 degrees, I think, or 50 something degrees, and then but he gives you point dot right. It doesn't tell you a finite value. It just gives you a lot of it. But so here, what will be cosine theta then? What is cosine theta? It will be adjacent over hypotenuse, right? And the adjacent one will be 3 over 5. You see, we didn't even have to figure it out. The signs is already 3 over 5. Is it positive? In the fourth quadrant, is cosine positive?
Yes.
Yeah. So that is correct. Yeah. We didn't have to worry about the signs. What about tangent theta? Tangent theta will be, opposite over adjacent, right? Yeah, so this guy is going to be negative 4 over 3, like this. And we didn't have to worry about the sign because he already gives it to us right here. But if we didn't use negative 4, instead we use positive 4, we then have to determine that tangent theta in the fourth quadrant is going to be negative, right? But these will be the answers for us. This one. Take a look at this, right? Take a look at the final exams from, let's see, this year. Let's go to, the mathematics department. There we go. Courses. 190. And let's take a look at in the winter 2019. Right? We had like about 95 students in the winter. It was offered for the first time in the winter ever. There are no math classes in the winter, by the way, but so they were offered the opportunity to take 190 or 195 in the winter for free, completely free, and the students, they all signed up, right? And we work with them for 3 weeks only. Everything that you're learning now in 6 weeks, they had to learn it in 3 weeks, and there were students who who attended, and they were really good students, some of them, yeah. And at the end, we took a look at how many people passed. We still have a record of them to see how they did in the spring semester for the 195, to see if it's worth doing it again. But it's the first time that they decided to do a bridge opportunity over the winter. So maybe you have to look out. Maybe there's something like that on the winter. But usually they do it for lower classes, like 190 and 195, because this material is not new to you. You have seen it before. All you have to do is put it together before moving on. The problem with doing this with later classes is that you need as much time as possible to learn it, right? And doing it in 3 weeks will not be productive. So here, let's take a look at what we can do. Take a look at number one. Can we do number one?
Mm-hmm.
Yeah, we can. What do? You make this equal to x, and then you try to figure it out. 9 to the x equals radical 3. 9 is 3 squared, right? So you have 9 to the x equals radical 3. So you have 9, which is 3 squared. 3 squared to the x equals... But you can figure it out. 1, done. Number 2, find an angle between theta... between 0 degrees and 360 degrees that is coterminal with negative 320. Do we know how to do this? Add 360 degrees to that. What do you get? 40. Is that good enough? Yeah. Again, they're not trying to trick you. They're trying to see if you know the essence of it, right? Of what it is or not. We'll 40 degrees, right? The coterminal angle to this between 0 and 360. Will that be the reference angle as well? What would be the reference angle of negative 320 degrees?
40. That'd be 40.
That would still be 40 degrees. Yeah.
Because on the front.
Yeah. So what about number 3? Do you know how to do cosine of 19 pi over 6? We should, right? But that's what we just did a couple of in the beginning of this today. What do you do with 19 pi over 6? You first find the coterminal angle, then you find the reference angle, and you determine the signs, whether they're positive or negative, right? Yeah. But you can do that, right? Now, do you know how to do number 4? Find the radius r of a circle if an arc of length 5 meters on the circle subtends a central angle of pi over 2. Yeah, we just learned that, right? This is the last few sections, and we're able to answer, what is it? Four more questions, except for log, 3 more questions for that. In pre-calculus, you're going to focus more on trigonometry. You're going to try to understand where the other trigonometric functions come from. Where do they come from, right? And in mathematics, by the way, we don't see okay, I need this mathematics to know how to do a problem in real life. That's not how math works. You invent mathematics is a concept thing, right? You have a bunch of things that you know how to do, but we don't know the applications for them. It is physicists, chemists, engineers that find all of a sudden, oh, this will be useful in here, this will be useful out there. But mathematics, we don't look after applications. So whenever you are in a class later on in mathematics, you will never say, when do I need this in real life? That would not be a question for mathematicians. You wouldn't, yeah. That's not a good question. For engineers, that would be a perfect question, right? Biology, for example, chemists. But for mathematics, nobody asks that question, like, when are you ever going to need this in the real world? It's like we may not know when things are applicable or not. Huh?
Last question. What is final? We put 21 questions in 2 hours, right?
2 hours and 15 minutes, yeah.
2 hours and 15 minutes.
Mhm.
Just 21 questions.
Yeah, some of them have parts, yeah, but overall it will be 21, 22. Sometimes they used to give you 24, I think, and they ask you to omit any 2 problems you wish. That was nice. But then after that, the committee says, well, you shouldn't tell them that, hey, no, this topic here is not important, you can get away with it. Every topic is important. You should know how to do so. And now they have 21 or 22 and solve all of them, yeah. Yeah.
So how much do you need to pass?
You should always aim for the best grade that you can, but 80% is the mark.
Which
Yeah.
is how many? 21?
Yeah.
Roughly 4.
Yeah. But they give you the points next to it, right? That so to tell you how much each part is worth, and you have no clue how to solve one, you can attempt it and just count that maybe you get 1 point partial credit if they feel nice, right? Yeah. But so what about number 8? Number 8, right? We are only focusing on the specific things that we didn't know before. It says the angle of elevation of the top of the Empire State Building in New York is found to be. Right?
Yeah, the homework.
Yeah, it's in the homework, right? Yeah. 11 degrees from the ground at a distance of 1 mile from its base. Using this information, find the height of the Empire State Building. And they say, you may leave sine, cosine, or tangent in your final answer. So if you did this, right?
Sine of 11.
Yeah, I think you'll get sine of 11 degrees, right?
Times 1 mile.
Yeah, times 1 mile, which yeah.
Times mile.
Mhm. Yeah, so if you want to know the units of the answer that you got, it will be measured in miles. Yeah, so you know that whatever answer you get is measured in miles, but it wouldn't matter. So, but you wouldn't have to know the value of sine of 11 degrees. That wouldn't. In mathematics, you can. In math, you can approximate this to the nearest 1,000th of an error if you want to, without the calculator. Yeah, in mathematics we can do this. It's really powerful. It's like 200 years ago, people were doing this without any calculator whatsoever. Computers were invented not so long ago, right? And they were able to do pi. You seen how many digits, right? And it is not reason that we know that many digits of pi. It's so many years ago where calculators weren't right around. So people had to be very creative on doing this, and we reconstruct mathematics on what went on in their heads, what were they thinking, right? And sometimes we say we probably think this is what they were thinking, right? But it's sometimes you see that it's not very difficult. It's hard to see it on your own, and that's why it's beautiful in mathematics. It's like it's so close, but yet nobody saw it, right? Only one person had the brightness to see it, right, differently, and it's nice, yeah. So that's how you know it was like they were really ingenious about doing things, because it's so simple, but yet nobody knew how to do these things, right? So the problem number 11, we don't know how to solve that yet, right? Well, you know, you have some methods, some techniques of doing number 11, and if you already know how to do that, that would be great, right? But we're gonna learn 3 methods of how to do that. Number 1 will be an addition method or subtraction method. Number 2 will be a substitution method, and number 3, I will give you an introduction to matrices, just how you can do this with matrices. Some of you might have an idea of how to do this with matrices because they started adding it in the curriculum at high school, so it's not a surprise that people have seen matrices, and I will just write it out just to know that you can do this. Let's see, and I think that's the only problem that we shouldn't know how to solve, right? That's just number 11th. That's the only problem that we are going to tackle. So here is another one, right? This is from the summer of 2018, last summer, right? And if you take a look at problem number 3, the previous final, they had the angles in degrees, right? When they ask you to find the coterminal angle, here they have angles in radians. And you see, they don't write radians next to it. They just assume that it's measured, right? Not in degrees. Do we know how to do number 4 now? Number 3, sorry?
Yeah.
Yeah? Number 4, the area of a sector. Yeah, so number 3, before, the final exam from before was given to you in degrees. Now it's in radians. Number 4, before, they didn't ask you about the area of a sector. They gave you the length, the arc length of a sector, right? But now they focus on the area of a sector, right? And so it's good that we are going through all of this so that we can answer different types of questions based on the same thing, right? Take a look at so let's see. Take a look at number 17th. Do we know how to evaluate sine of negative 210th? We pull the negative out, right? And then we have negative sine of 210th. The identity that I gave you might be useful there. And then you find the reference angle of 210th. 210th will be in the 3rd quadrant, and sine there will be, so you can figure it out how to do, yeah. But it's nice, so the questions are not very difficult, but it can be very annoying if you are hesitating on your answer, like is it positive, negative? You have to have a way of we're determining that. Look at number 8 for this one. Suppose that theta is between 90 degrees and, so in other words, theta is in which quadrant? Second quadrant. So that's all they're saying. Suppose that theta is in second quadrant and sine theta is 2/9. Find cosine theta. Right? Yeah. So let's do something like that, right? Let's do something like that 8, and that will be the last question for today. So here is one last example. Suppose that theta is between 90 degrees and 180 degrees. And 180 degrees. And you're also given the sine theta. Yeah. Let's put 7 over radical 13th. Sorry, 7 over 13th like this. Suppose that 90 degrees, right, is less than theta and less than 180 degrees. And sine theta is that. Find cosine of theta and tangent of theta. So let's see if we can do this, right? So here is this. Here's x and here's y. And which quadrant are we on? Second quadrant. There you go. And we don't even know what theta is. That's like really not necessary. But we're in quadrant 2. And we're going to draw a little triangle there. Like this. Like this. And like that. So here is theta right here. Sine theta, what they gave you here is opposite over adjacent. Hypotenuse. Opposite over hypotenuse. So let me just take this out a little. Copy this, and there you go. Sine theta is opposite over hypotenuse. They gave us that this is equal to 7 over 13th. The hypotenuse of this guy over there is 13th, right? And we never put a negative on the hypotenuse. What about 7? What is 7 going to be? The little height of the triangle, right? Is it positive or negative 7?
Positive.
Yeah, because this is the y component of the point, and it is pointing upwards. It's positive anyways, right? How do we figure out the bottom part, the x component here? We use Pythagorean theorem for that. So that is going to be the square root of what? 13 squared, right? Minus 7 squared. And this is going to be 13 squared is what? Yeah, 169th minus 49th. And that's just going to give you? Yeah. What is it, the square root of?
120.
Yeah, 120. And the square root of 120, right? We don't know what it is. If you want to simplify this, right? Yeah. So the square root of, so if you put 4 times 30, right? So 2 radical 30, right? If you want to, rationalize and simplify things out. So let's see if we can figure it out. The values for cosine theta and tangent theta. So what is cosine theta in this case?
Adjacent over hypotenuse.
Yeah, so it will be adjacent over hypotenuse. Right. And adjacent here will be 2 radical 30 divided by the hypotenuse, which is 13th. Right. And what about tangent theta? Yeah, that will be opposite over adjacent, yeah. And what is this going to be? Yeah, it will be 7 over square 2 square root of 30, right? Yeah, but these are going to be the answers for that. It's not so bad, right? Yeah. Mm-hmm. So here is something that. Yeah. Oh, sorry. I forgot that cosine should be negative, right? Yeah. The reason why it's negative because this guy over here, this is negative, right? Yeah, and is also tangent. Tangent is negative, right, as well. Yeah. So thank you. Yeah, I was gonna write something bad, and yeah, I would have gone home and said I should have realized it. Yeah, it's fine. So here is something that for the future, right, which is not so bad here for later on, right? Imagine that I give you a triangle, right? Any triangle. It doesn't have to be a right triangle, like this, right? And what you know here is that this guy here is theta. You could have used any one of the angles. I'm just putting this one as one. You can tilt the triangle and call that another angle theta. So I just choose any one of the angles theta. And what I do is I'm going to draw a little right triangle by dropping this point right here perpendicular to the base right here, right? So the length on the bottom, this bottom right here is going to be the base, right? And the height of this thing that I drop perpendicular to the bottom one, this is going to be the height, h, right? Height. Right? And imagine that you know the length of another side. Say you know that this length right here is say we know this length. This length. How do you want to call that length? L? Yeah, L. What will be the area of this triangle? The area of this triangle, yeah, is going to be 1/2 base times, yeah, height. And we know that this will be 1/2 the base. Let's call the bottom base B, right? Let's call this B, just for base. And the height, right? Let's call it H. But you don't know the height. You know theta and you know L, right? What do you know about sine theta?
I mean height
Yep.
over the one you know, L.
Yeah, so sine theta will be opposite, right? Over hypotenuse. And it turns out that by the diagram that you drew over there, opposite will be the height divided by L. And hence you have this 1/2 base B times A. So E.
Sine L times the sine of H.
Yeah, because what you do here is, hey, I need H. So you multiply both sides here by L, and you get this nice result that H is equal to
L times sine theta.
L times sine theta. So we are going to have this H as L times sine theta. And we get this nice result that this guy is going to be 1/2 base times the length of the other guy times sine theta, where theta is the angle between them. So this is a nice property to know. A very nice property to know later on. Because what we do later is we want to compute this faster. We want to be able to compute the area of triangles that are floating in space, right? And we use something like this, but we don't know how to measure the angles precisely. So what we do is have you ever heard of the cross product? The cross product. So have you ever heard of vectors? Yes. So vectors are not numbers, right? So we need to define new operations on vectors. We define the inner product of two vectors. We call it later the dot product. And we define the outer product as the cross product. So these are new operations on vectors. It turns out that to figure it out sine theta, we will have to use one of those operations. And it will tell us what sine theta is, right? But anyway, so for tomorrow, right? For tomorrow, you have to complete these sections 6.3 for homework. So if you go to 6.3, right? 6.3, you have to complete that for homework. And tomorrow we're going to do systems of linear equations and systems of non-linear equations. So that is the last two sections that we have in our schedule. So for Monday you will have to be able to answer all of the questions, right? But we're going to focus on what we're learning today, this week, 4.3, 6.1, and all the way to 10.8. Yeah, for the quiz tomorrow, we're going to be focusing on 4.3, right? Logarithmic functions, 1 or 2 functions from there. We're going to take a look at 6.1, 6.2, and 6.3. Those are going to be the main focus of the quiz. Just these 6. For 4.3, I might put 1 or 2 questions from it, but the main focus will be 6.3, 6.2, and 6.1, right? So just keep that in mind that these are the sections for our quiz, but the priority will be on these ones here. This will be the priority on that, right? But I will see you guys tomorrow.